Hi everyone. This is Gobi here, Dr. Gobi from Faculty of Engineering, Multimedia University. Right. So today I will be taking some of your time to explain about energy efficiency. Right. So we will be probably taking about 20 minutes. So I wish to actually explain to you probably at the end of this session since June is actually a Father's Day month, I would say. So probably you can probably look into ways to help your dad, your father, to minimize on the energy bill. Okay, every time, every month, when your father gets the bill, so probably you can see his expression, especially when all of you are sitting in at home during this pandemic, doing the online learning. So you're using a lot of aircon, a lot of appliances, you're using a lot of electrical equipments, which is going to consume a lot of energy, right? So whatever we are going to talk about, especially on the energy efficiency today, I believe that you'll be able to, at the end of the day, to save, to help your father to save on the energy bill. Okay. With that, I wish to start. All right. So if you have any questions, of course, you can put your questions in the comment down here. All right. So I'll just share. Is it okay, Brian? Is it clear? Okay, let me share it. Okay. All right. So welcome back again. Now, when we talk about energy efficiency, when we talk about energy efficiency, simply, I put it in a very simple terms. That is actually using less energy to perform the same task. For instance, if you are actually using an aircon in your room, you are doing online learning, and you are trying to, obviously, you will be using aircon, especially nowadays, it's very hot outside there. So if I can find a way to keep my room cool enough, that means you're comfortable, right? That means the aircon is going to do the same job, but then at the same time, it actually consumes less energy, right? So it consumes less energy, but it really still keeps the room cool, for you to work comfortably. So that is actually what we talk about energy efficiency. That means we try to use less energy to perform the same task. Now, because don't try to have the wrong concept that, for instance, if you switch off the aircon, if you switch off the aircon, that is not called energy efficiency, because if you switch off the aircon, that's a different task. The aircon is not working. Of course, you're not going to feel comfortable in your room, and obviously your electricity bill is going to go down. But that is not energy efficiency, because obviously you switch off the aircon. That is not what we are talking about. What we are trying to say is you still use the aircon more efficiently, you still feel comfortable to work in the room, but the energy bill will go down. Okay, so that is what we are actually talking about energy efficiency. Simple as that. Now, a little bit, I believe that at the school you have actually learned, when you talk about it. So you need to understand this: what is energy, what is power, and then time. If you look at energy, this is what the your bill is actually calculated from energy, yeah, the amount of electric energy that you use, and then it's actually simply given by the power, okay, power, and multiply with the time. So if you look at from the mathematical point of view, it's very clear cut. It's very clear cut that if if you want to reduce the energy, okay, if you want to reduce the energy, so what you need to do is you just have to either reduce the power, okay, you reduce the power, don't use so much of power. That means, in other words, don't use big kettle. A big kettle will require bigger power. So instead of using bigger kettle, you use smaller kettle. So that means you use smaller power, and therefore you use smaller energy. Or the other option is, you still have the kettle, but you don't boil the water like very frequent. That takes about in a day you are actually using 1 hour. Okay, you are just operating the kettle for 1 hour instead of half an hour, right? So that means you minimize on the time of usage. When you minimize on the time of usage, again, that will help you to minimize on the energy. Got it? So the power is actually the rate at which the work is being done. That means you if you not look at all the appliances that you have, if you just walk into your kitchen today, you have a toaster, you have a electric kettle, you have a microwave oven. If you just look at underneath or at the side, you will actually see a small nameplate, we call it, with some some barcode or maybe a QR code, and we will have some uh, kilowatt or what is a watt of that particular equipment. So that is actually the power. So it is clearly written there. So that means when you're operating that particular equipment, and that is the power that is going to take in. Okay, that is a power that is going to take in. So depending on how long you're going to use that equipment, accordingly the energy will be. So I'm going to elaborate more on that. Okay, so I like to explain in this case. Okay, probably you all can put some comments down there. Okay, you can probably put some comments down there if you are able to give a comments quickly to me. Now let's look at this case studies. If you understand this, I think it will be just like that for you to understand about energy and then helping your father to reduce on the energy bill this month, June. Remember, it's a Father's Day. It's a Father's Day month, so you have to help him. So okay, if you look at it, we have a dash. Okay, as you can see, is a dash there, right? Okay, clearly, and Ahmad is trying to push that dash from one point to another point, because probably he is like rearranging the room. Now, obviously, there are some things on the desk. Some books are there. And then he's going to push. He's going to push. Now, my question is, what are the options that probably Ahmad has in this case? What are the options that Ahmad actually has in this case? Anyone can give me some comments, and that would be good. Okay. So, what are the options that Ahmad actually has? Okay, number one. Yes, you can just push as it is. That means, as you see now, you have a dash. Okay, this is the dash with some books on top of it. So that means Ahmad is going to push. Okay, he's going to push from point A to point B. So in order to push, he needs to apply a force, right? You know that we need to apply a force. That means in order for me to apply a force, I need to have power, enough power to apply the force. So I need to have enough power to push that dash. Okay? Okay, to push the dash. All right. So when I do that, of course I can push. Ahmad will be able to push from point A to point B. Fine, no problem. But what are the other options that we have? Okay, the other option that I have is I can probably remove all these books, right? I can actually remove all this, whatever I have on top of this desk. I remove it first. That means I take all these things, put it down. Okay, then I will push. Then Ahmad, okay, the Ahmad is going to push empty desk. Okay, empty desk. Now, what happened? When we look at these two options, option one with all the books on top of the desk, option B where with the empty desk. Obviously, option B, Ahmad is going to apply lesser power. He no need to struggle to push. He's going to use lesser power. So if you ask him to push the whole day, he might be able to do it because he's using less power, meaning less energy. So that means you will be able to push the whole day because you will have enough energy to do so. But then if with the book on top of the desk, and then you are expecting him to push the whole day, he may collapse by noon because he's applying high power to push the desk, which is heavy. So he will use a lot of energy to do that. Therefore, he may not able to. He will get exhausted. By noon probably he will collapse. Okay, so this is another some analogy for you to relate between the power and the energy. All right. Now, let's go a little bit into a real life example here, whereby this. I believe that all of you have seen this kettle. Okay, all of you have seen this kettle before. Okay, so the kettle, as I said just now, that of course we are talking about electric kettles. Let's say this is a 2 liter kettle. That means you can actually fill up water up to 2 liter. Okay, inside this kettle to boil it. And then the rating, we call it the rating. That means if you see underneath that kettle, you will have a small write up. It will be written there, 2000 watt, or maybe 2000 watt is equivalent to 2 kilowatt. So you will be able to see this. Now again, I want to ask you a question. If and then the kettle takes about 15 minutes. The kettle takes about 15 minutes to boil 2 liter water. That means when you fill up 2 liter water and then you turn on the kettle takes about 15 minutes to boil. Okay. So now I want you to look into the usage. Okay. Well, let's say probably you want to tell your mother, because usually you can actually try to create awareness and then tell your mother, because, obviously mother will be using kettle. Okay. How much that we are using, how much electricity bill, from the full bill, whatever, let's say 300 or 400 ringgit, what is the amount of portion, the portion of energy bill that actually comes directly from this electric kettle? So you can actually calculate. I'm actually giving you that input now. Okay. Now look into this. Kettle takes 15 minutes to boil 2 liter water. Right. Now, if I'm going to use this kettle for, okay, I'm going to use the kettle for 2 times. Okay, that means I'm going to use it in the morning, and then I'm going to use it in the afternoon for morning tea, and then probably evening tea or afternoon tea. So what I will do is, okay, 2 times. That means I'm using this kettle for 30 minutes in a day. 15 minutes plus 15 minutes, 30 days. Okay, or 30 minutes, or I will just say 0.5 hour. Correct? In a day. Okay, so that means I'm using it for 0.5 hour. Okay, that is option part A. If let's say I'm actually your mother actually using it very frequent, even for some drinks, just a little of hot water, you keep on using it. So that means she use it at least for 4 times in a day. 4 times 15, that means it's going to be 60 hours. That means this is going to be 1 hour of usage. Okay, the kettle is going to be 1 hour of usage or half an hour of usage per day. Okay, per day. We are talking about per day. Okay, clear? Okay. Now, if I want to calculate the energy for this, okay, let's look into it. Now, if 0.5, okay, I just put it, if all of you have the calculator with you, okay, 0.5 hour, and then I'm going to multiply with 2 kilo, okay, watt. So I'm actually talking about energy, which is 1 kilowatt hour. Okay, that is for the option A. Option B, of course, is 1 hour multiplied by 2 kilowatt of the kettle rating. So that actually gives me 2 kilowatt hour. That means the energy for option A is 1 kilowatt hour. Energy for option B is 2 kilowatt hour. Okay, you can simply multiply. Let's say if the unit cost, okay, 1 unit cost is equivalent to 1 kilowatt hour. Let's say if I just take 40 cents, okay, 0.40, okay, that means I'm talking about 40 cents, okay, so that will be 40 cents. This one, if I multiply with 0. Okay, 40 again, then that will actually gives me 80 cents, right? 80 cents. Okay, and this one will give me 40 cents. That means for option A, when your mother used for 2 times, is going to take in 40 cents out of your electricity bill. 40 cents per day, per day. If option B is going to take 80 cents, that's only per day. Yeah? If you multiply by 30, okay, you just multiply by 30, okay, that means for option 1A, so you're actually talking about 12 ringgit, okay, that means option A, you are actually talking about RM 12, and option B, you are talking about RM 24. Got it? So that means if your father is actually paying 300 ringgit every month for electricity bill, if let's say your mother always use option B, that means she will use a kettle 4 times in a day. If let's say she stop using that kettle, your father will be able to save 24 ringgit in a month. This is only out of this kettle. Okay. So I hope today you will actually go back to your mother and say, Mother, please stop using the kettle. Okay. Right. Now, okay, the same example, I'm actually giving another way how to look into it. Okay. This is another point that we have to understand when you talk about energy efficiency. Now, the previous example, what we are trying to do here, if you notice, is we are trying to play around about the hour. Okay, we are trying to play around with the hour. That means if you use less, of course you consume less. Got it? You use less, that means you consume less. You play around with the time of usage. Now, there's another point that we need to also look into it. Now, if anyone can also write a comments for this, that if that the kettle is actually again the same kettle, everything is the same, just that if your mother every time when your mother boils water, whether she puts two, she actually fill up 1 liter of water, or it's going to be a 2 liter of water. Remember, this kettle is a 2 liter electric kettle. Now whether you're going to fill up 1 liter kettle, that means you actually fill up only half of the capacity of the kettle, and then you boil it. Okay, versus part B, you fill up full. You fill up full and you boil it. Now the question that I want to ask, whether the power consumption is going to be lesser. That means maybe some of you think that, if it is a 2 liter water, is going to consume, of course, the power which is the 2 kilowatt, because it's a 2 liter electric kettle. But then if I use half of the water, then the kettle will be using, the kettle will be using only 1 kilowatt, half of the power. So that is actually the wrong concept. That is actually the wrong concept, because the kettle will still need to heat up the whole kettle, which is meant for 2 liter, right? So you will actually see that the kettle will more or less still use 2 kilowatt, even though more or less will still use 2 kilowatt, even though you are actually boiling 1 liter water, okay, compared to a 2 liter water. Okay, so don't think that, if you reduce the water, 2 liter watt kettle, but then you are usually using it only 1 liter, you think that the power is going to be half. No, 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 right? It is still more or less going to be the same, because the kettle still have to work to heat up the entire kettle, even though your water is actually just about half a capacity, okay, 1 liter. So that means, please create the awareness. Please tell your mom that if you want to boil, if it is a 2 liter electric kettle, please fill up total full. 2 liter means 2 liter, boil it. Then probably if you have excess of water, hot water, you can probably transfer it into a flask where you can retain the heat. So whenever you need a cup of coffee, you don't boil it again, but just take it from the hot water from the flask, and that's it. Okay, so in that case, you actually save on the energy. Right, so little bit on this. So this is actually that I keep on telling you about electricity bill. If you look at electricity bill that your father always get it, if you please look into it, please look into it, because you need to help him, to minimize on the energy bill, because it's expenses which you can help him to reduce it. Okay, it's just a matter of how you use that equipments. Now, if you look at the charges, as I mentioned to you, if you look at the bill, they always uh, measure what is the kilowatt hour, which is actually the energy. Now, and then there is a different rate. If you look at it, they have a different rate of charges depending on how much you use. That means if you are using 500 kilowatt hour, if you are using 500 kilowatt hour, what they do is for the first 200, they charge you 21 cents, 21.8 cents. Okay, cents, cents. But then for the next 300, next 100, they're going to charge you 33.4 cents higher. Look at it. Then the balance, another 200, right? So it's going to be 51.6 cents. Wow. Look at it. Okay. So meaning to say that if you are using 500 kilowatt energy, 500 kilowatt hour of the energy in a month, it is not going to be a flat rate. No, it's a block tariff. That means first 200 you get cheaper. But as you go higher and higher, the rate is going to go up and up. That's why the electricity bill can actually shoot up very high when you use more. So what you have to do is we need to find a way to actually use less energy, but to do the same job. As I said just now, we still have to do the same work, same task, but using a less energy. Okay, like the example of the kettle I gave you, right? You still can actually use the same kettle, but what you do is don't try to use it up too many times. Don't use it too many times. Okay, try to minimize the usage. And secondly is try to use full load. That means if it is a 2-liter kettle, boil the 2-liter water and then store it if you need, right? Right. Any comments? Probably I can answer. Otherwise, I'm done. I hope that you have actually learned something about energy efficiency and you can actually implement this. Okay, start with a kettle, and you can do the same thing for many other appliances. Like for instance, aircon. Okay, probably aircon. I can actually give you a few tips on how to minimize the energy. Help your father to minimize on the electricity bill. Now, since you're going to be in your room, now what you do is you actually just when you enter into your room, right? Make sure that we call it that don't eat up your room. That means, in other words, don't let your sun eat, right? Sun eat to come into your room. So if you have a night curtain, right, which is always dark, always close it. Depending on the direction of the sun. Don't let the sunlight to come into your room, which will actually increase the heat into your room. So try to close it with the night curtain. Okay. Then when you turn on the aircon. When you turn on the aircon, what will happen is close your room. Okay, make sure the door is closed. The smaller the space is, the aircon is not going to use a lot of power to cool down uh, the space. But if you leave the door open all the time, or you go in and go out all the time, you just like every 10 minutes you open the door and go out and then come in again. Obviously, what will happen is every time you open the door, the heat is going to be added into your room. So then aircon will start to again work harder to bring down the temperature again, right? So in that case, what will happen is the aircon will continuously work harder. It will use a lot of power and hence the energy. Okay, so one of the biggest equipment at home which use a lot of energy is actually the aircon, right? So try to, number one, close the night curtain. Make sure there's no light, sunlight is coming into your room. Close your door. Close your door all the time. Okay, and turn on the aircon. And aircon will just use for a short period of time. Once your room has cooled down, because your room is closed, your aircon will stop working because it's already cooled down. Got it? So that means you use less energy. So with that, thank you very much. So I hope you have benefited. See you again next time. Bye-bye.